Welcome to the Expeditionary Airfield Lighting System, Charlie Training. In this lesson, you'll learn how to safely and effectively install, operate, and recover the EALS-C to support airfield operations in expeditionary environments. Whether you're working on a bare base, a damaged airfield, or a temporary strip, EALS-C is a critical asset for restoring and maintaining airfield operations. Let's begin with an overview of the EALS-Charlie system. EALS-C provides temporary lighting for bidirectional, minimal operating strips, up to 150 by 10,000 feet. It can be set up on a variety of surfaces, including concrete, snow, sand, and grass. The system supports both military and commercial aircraft, and it offers 5 intensity settings for night and low visibility operations. It's important to remember that EALS is not designed for permanent installation, but rather for rapid deployment and recovery in expeditionary or contingency environments. Team composition and equipment. A standard EALS-C installation team consists of 6 members and 2 general-purpose vehicles. The system includes a comprehensive set of components: edge and runway lights, threshold and end lights, approach lighting, PAPI units, obstruction lights, distance remaining markers, sign lights, wind cones, taxiway lights, cable protectors, and solar panels. Each component comes with a spare, stored in the trailers, ensuring redundancy and reliability during operations. Pre-installation planning. Before installation, the team must confirm several key details: the location of the runway and taxiways, the direction of aircraft takeoff and landing, the placement of PAPI units, and whether it will be a 2 PAPI units install or a 4 PAPI units install per each side of the runway, the location of any fixed arresting gear or mobile aircraft arresting system, also known as MOS. The team lead will determine the required installation configuration and assign tasks, breaking down equipment and storage locations for the 2 or more small teams. Installation sequence. Let's review the sequence of installation. The process is driven by mission priorities and may be adjusted based on the area of responsibility. Typically, the team will start with an expedient basic install using solar power only. Wired installation is added next, followed by generator connection, additional approach lighting, a second set of PAPI units if needed, distance remaining marker signs, wind cones at each runway end, and finally, taxiway lights. Generator placement and power planning. When planning generator placement, remember that one generator should ideally be at each end of the runway, located between the PAPI and approach lighting, or within 1,000 feet of one of them. Generators should be placed no closer than 60 feet, but preferably 200 to 600 feet from the runway edge. The team will also determine which runway circuits and if 2 or 4 PAPI units will be installed. System characteristics and cabling. Unlike legacy airfield lighting systems, EALS does not use a constant current regulator and does not operate in a series loop. Instead, it is powered by up to 2 independent 5 kilowatt, 60 Hz, 120 or 240 volt AC diesel generators. These generators are capable of running all airfield lights, except for obstruction lights, which operate on solar and batteries. The system uses bayonet-style connectors with straight and T connectors to split off parallel runs. Cables come in 205, 50, and 10-foot lengths, and the 12-gauge wire reduces overall system size and installation time. Packaging and trailer design. The EALS system is packaged in up to 8 air transportable trailers, which fit within the space of 4 4-6-3 L pallet positions. The trailers are designed for tandem towing with a minimum 1.5-ton truck, equipped with a pintle hook. Trailers can be towed in a train of up to 3 at a time, supporting efficient installation of lighting equipment and cabling. When towing, do not exceed 25 miles per hour, and keep the maximum hitch height at 18 inches. When positioning trailers, Use manual methods only. Do not use the truck to back in or park trailers into their final positions. Trailers 1 and 2 are identical, as are trailers 6 and 7. Cables are stored with sockets on the reel first. Each trailer contains a tow bar, charging port, trailer tongue storage, and locking tabs for the doors. The parking brake is engaged when up and disengaged when down. Generator setup and safety. Each EALS kit includes 2 generators, stored in trailers 6 and 7. The system operates at 240 volts AC, which is much safer than the high-voltage legacy systems. However, the lower voltage, smaller wire size constrain generator placement due to potential voltage drop. If an auxiliary fuel supply is used, the generator should be placed within 25 feet of the fuel source. The generator has remote start capability, activated using the wired controller. The remote start controller is located on top of the generator. For grounding, drive the ground rod within 5 feet of the generator using a minimum number 6 copper ground wire. Before starting the generator, check the coolant level, turn on the battery switch, check the fuel filter and water separator. Drain water if present. Check oil levels. Set the selector switch to 120 or 240 volts. Place the dead crank switch to normal and ensure all connections are tight in the termination compartment. To start the generator manually, place the engine control switch to prime and run to engage the fuel pump and allow priming. Verify the graphical user interface screen is displayed. Crank the engine by turning the master switch to start. Verify frequency and voltage on the screen. Adjust as necessary, and run the generator at no load for 5 minutes if possible. Load can be applied immediately if necessary. Close the AC circuit interrupter by pressing the appropriate switch. To set up the generator for remote start, turn on the DC control circuit breaker. Turn the master control switch to prime and run, and turn on the remote start toggle switch. If a fault is present, press the fault reset button. On the screen, select the About menu, hold the second soft key for 5 to 10 seconds, and enable remote mode. Once enabled, the generator can be controlled via the wired system controller. Lighting components and placement. Let's talk about the lighting components and their placement. Threshold and end lights are spaced 10 feet apart from the wings of the runway threshold using 10-foot cables with green lights facing the approach. Place them in 2 groups of 5, with the innermost lights in line with the runway lights, for a total of 10 lights in a winged-out configuration. Runway edge lights are spaced 200 feet apart using 205-foot cables with a white lighting pattern between white and yellow lights. The white and yellow pattern is used for the first and last 2,000 feet on the runway for bidirectional operations, and the last 2,000 feet for unidirectional. The yellow light faces toward the center of the runway, and the white light faces toward the threshold. Obstruction lights are red and used to mark any hazard on the airfield that could cause damage to aircraft. These are solar-powered, but can also be charged via the AC line. Taxiway lights use the AV70 frame, which is self-contained with solar and removable battery. Place 2 lights 5 feet apart at each taxiway entrance, 2 feet off the edge. On straight sections, install taxiway lights every 50 feet, and no more than 25 feet apart on curves. Use reflectors away from the runway to free up lights for other taxiways. Distance remaining markers are placed on the right side of the runway from the pilot's view, every 1,000 feet, starting 1,000 feet from the runway end. Place them 50 to 75 feet from the runway edge, or no more than half the runway width, and keep them away from PAPI units to reduce pilot confusion. The distance remaining marker light is placed in front of the sign, 8 feet away, and angled to illuminate the sign. Cable protection strips come in 42-inch sections. They have a center slit for cable protection. They interlock to keep pieces stable. Taxiway reflectors are 2-piece interlocking cylindrical posts with 360-degree visibility. The wind cone comes in 9 pieces, made of aluminum, and is quickly assembled and stored. Approach lighting systems. Now, let's discuss the approach lighting systems. There are 2 main configurations: the medium-intensity approach lighting system with runway indicator, or MALSAR, and the short simplified expeditionary approach lighting system, or EALS-C. MALSR is used for Category 1 lighting and has a 2,400-foot approach. EALS-C is used for expedient airfields and has a 1,400-foot approach. The approach lighting system includes standalone steady burning lights, barrette steady burning lights, and sequence flashing lights. The crossbar, a key feature of the approach system, is a straight line of lights perpendicular to the runway centerline, typically located 1,000 feet from the threshold. It helps pilots visually align with the runway during approach, especially in low visibility. The crossbar consists of several steady burning white lights that are evenly spaced and have 5 intensity levels. System control. The system control consists of the primary wired control system. The controllers use a Windows-based platform and touch screen to operate the AVH-MALS software. To operate the HMALS system controller, first power on the tablet by flipping the battery toggle switch, then press the main power button. The control application will launch automatically. If it doesn't, simply click the desktop icon. Confirm a successful connection by looking for the green Connected status in the top left corner. If the status is yellow, ensure the PLC transmitter is switched on. To control the lights, first select your mode, either visible or night vision. Next, select a light group, such as the runway or a specific PAPI system, and set the desired intensity level. Finally, press the Confirm button. The indicator light for that group will turn from yellow to green, confirming the command has been sent. For quick activation, you can also use the preset buttons to turn on all lights to a low setting. Your airfield lighting is now under your control. The IR remote provides local, on-the-spot control for individual AV426 and AV70 airfield lights. Remember, this remote does not operate the SSBL. To begin programming, a passcode must first be entered on the remote before the fixture will accept a signal. Once initiated, you can select the light's operational mode. Choose from Always On, where the light remains on continuously, Standby, which turns the light off, or Dusk to Dawn for automatic operation using the daylight sensor. You can also select the light's intensity and check the battery status, with the light flashing to confirm its voltage. Each of these commands requires a specific key sequence. For the exact passcodes and a complete guide to all operations, always refer to your technical manual. There are also 2 handheld controllers in Trailer 3, which run on rechargeable batteries and have a range of just under a mile. These control the edge, threshold, and taxiway lights for installation and maintenance. Warning: make sure you receive clearance to use these system controllers before use, especially in areas overseas. Approach lights, PAPI units, and distance remaining marker lights must be turned on manually. The PAPI system includes 4 light head assemblies, 1 battery box, 1 digital inclinometer, 2 solar panels, and 20 ground stakes. The battery box is a rechargeable 50 amp-hour, 24-volt DC pack with an integrated controller. If AC power is lost, it automatically reverts to solar power. Each PAPI system has 2 300-watt portable solar panels, which can tilt from 0 to 70 degrees and should be pointed toward the equator for optimal charging. Each PAPI light head produces white and red beams, with red on the bottom and white on top, separated by a horizontal transition line. The lights are interchangeable and can be installed in a 2 or 4 box configuration. The first PAPI is positioned at least 50 feet from the runway edge, with each subsequent unit 30 feet apart, perpendicular to the center line. Before aiming the PAPI units, calibrate the inclinometer and adjust the angle for the proper approach path. The tag member. Successful and rapid deployment requires a 6-person installation team, divided into Team A and Team B. Each 3-person team is comprised of a driver, a cable reel operator, and a tag member. The tag members operate primarily on foot. Their mission is to ensure each light fixture is placed at its precise location and properly connected to the primary AC circuit as the vehicle moves along the runway. Team installation steps. Let's review the team installation steps. Team A is responsible for the EALS-C approach, edge lights on the runway side as shown here, distance remaining marker signs. Team B handles the PAPI side threshold and edge lights, the PAPI units, and supports cable runs. Team A begins by paying out 205 feet of cable from the generator to the outboard threshold and end lights, installing 5 threshold and end lights 10 feet apart, and connecting T-connectors as needed. They then pay out cable toward the approach, install the EALS-C approach, and continue installing edge lights until the opposite threshold is reached. Team A also places distance remaining marker signs and lights at the appropriate intervals. Team B starts by installing 5 threshold and end lights 10 feet apart, then pays out 205 feet of cable and places edge lights, dropping a T-connector at the PAPI location. They continue running edge lights, drop off the PAPI cases and solar panels, and pay out cable to the battery box location. After reaching the opposite threshold, they return to the PAPI location and install the PAPI units. To prepare lights in advance to minimize stops, use T-connectors for sign and PAPI drops, and keep the tag person with the truck and trailers. Communication and coordination between teams are essential for efficient installation. Mauser approach installation procedure. Let's now take a look at the Mauser approach lighting system procedure. This system provides Category 1 instrument approach capability and requires careful attention to safety and sequencing. Step 1. Preparation and safety. Begin by gathering your required equipment from trailers 4 and 6, plus the SSFL units from trailer 1 or 2. Safety reminder. The large triple barrette battery box is heavy and requires a 2-person lift. Never attempt to move this equipment alone. Step 2. Deploy cabling and steady burning lights. Starting at the runway threshold, deploy your 205-foot AC cable. Attach the AC breakout cable with T-connector, then run the 50-foot cable to your first station. Now you'll establish your steady burning light stations. At each of the 200, 400, 600, and 800-foot stations, deploy 5 standalone steady burning lights, that's 5 SSBLs, in a line abreast formation. Step 3. Deploy the 1,000-foot barrette station. At the 1,000-foot station, place your 3 barrettes and the large battery box. Unfold and lock each barrette, ensuring the light heads face toward the approach direction. Position 1 barrette on the extended runway centerline, with the other 2 barrettes 30 feet to each side. Critical step. Connect the 3 barrettes to the large battery box using only the 40-foot DC cables. Do not connect AC lines directly to the barrettes. Then connect your main AC power line to the battery box using the breakout cable. Step 4. Deploy the 1,200 and 1,400-foot stations. At the 1,200-foot station, deploy 1 barrette and 1 small battery box. Connect them with the DC cable and attach the 100-watt solar panel to the battery box. Repeat this same single barrette setup at the 1400-foot station. 1 barrette, 1 small battery box, DC connection, and solar panel. Step 5. Deploy and configure sequenced flashing lights. Now for your final 5 stations. At the 1600, 1800, 2000, 2200, and 2400-foot stations, deploy 1 standalone sequenced flashing light at each location. Pay close attention to the sequence configuration. Set the furthest light at 2,400 feet to sequence number 1. The next light gets 2, continuing in order, with the closest light at 1,600 feet set to sequence 5. Step 6. Final system verification. Before declaring your system operational, verify 2 critical settings. First, ensure all Mauser components, both barrettes and SSFLs, are set to the same approach number, either APR1 or APR2. Second, turn on all battery switches on every battery box to make the system fully operational. Your Mauser system is now deployed and ready for service. For any troubleshooting or maintenance needs, always refer to your EALS-C technical manual. Recovery and storage.
When it's time to recover the EALS, reverse the deployment sequence, recovering lights at the end of each parallel run. Make sure the sockets are on the reels first. Avoid dragging connectors to limit wear. Each trailer charges fixtures using standard 90 to 270 volts AC wall outlets. Each rack level operates as an independent charging circuit with daisy-chained lights. Critical warning: always turn light fixtures off before loading. Leaving them on damages battery life. Follow this procedure. First, follow the loading diagrams inside each rack door. Start electrical connections from the rightmost column working left. The pattern is simple. Column 1, pins front. Column 2, sockets front. Column 3, pins front. Column 4, sockets front. Load fixtures according to trailer assignments. Trailers 1 and 2 handle edge lights and approach indicators. Trailer 3 specializes in taxiway and obstruction lights. Trailer 4 carries mixed inventory, including Mauser systems. Once loaded and connected, secure everything with buckle straps front and back. Key points: fixtures off before loading. Start connections from the right. Secure with straps. Follow door diagrams. This system keeps your equipment mission ready.
Safety reminders. Let's review some critical safety reminders. Always ground generators properly. Check all connections before powering up, and use the correct personal protective equipment, including gloves and eye protection. Communicate clearly via radio during installation and ensure all hazards are mitigated before beginning work. Conclusion.
Proper EALS setup ensures safe, effective airfield operations in any environment by following these steps for installation, operation, and recovery. You'll help ensure mission success and the continued safety of air crews and ground personnel. Thank you for completing this EALS Charlie training.